Alright, so this is problem number 3 from the lab. So the first step would be to put the solution in standard form. And to do that, we would have to get rid of this coefficient right here. So we would divide all the coefficients by x. So this would be dy dx plus 2y over x equals 10x. And the second step would be to identify p of x, which would be the coefficient in front of y. So we would make the 2 over x raised to the power e. So e raised to the power 2 over x, and then the integral. This would be e to the power 2 ln x, and then log rules would make this equal x squared. And the second step would be to multiply the p of x, which is x squared, by the entire solution. So it would be dy dx plus 2y over x equals 10x. So this would be x squared dy dx plus dy, because that x cancels out. It would be dy, not dy, be 2y x equals 10x cubed. And then here we would identify the f prime and the g prime for the product rule. So it'd be 2x, so f prime, and this would be g and g prime. And this would make the product rule. So this derivative would be x squared y. And then our third step would be find the integral of both sides. So it'd be integral of derivative of x squared y equals the integral of the right side, which is 10x cubed dx. So the integral and the derivative cancel out, and we're left with x squared y equals 10x to the power 4 over 4, which is just 5 over 2 simplified, x to the power 4, plus the constant of integration. And the final step, step number 4, would be to isolate the y. So we divide both sides by x squared, which leaves us with y equals 5 over 2 x squared plus c over x squared. And because it's an IBP problem, we need to plug this into that, because this is just the general solution and not the final solution. So we would basically plug in 1, 1, and 3, which is the x and y. So it'd be 3 equals 5 over 2, 1 squared plus c over 1 squared, which leaves us with 3 equals 5 over 2 plus c. And then we just subtract 5 over 2 by both sides to get the c by itself. So it would be 6 over 2 minus 5 over 2 equals c, which leaves us with c equaling 1 over 2. And then we would plug this c back into the general solution to get the final solution, which would be y equals 5 over 2 x squared plus 1 over 2 x squared. And that would be the final solution.